Hearing an oncologist say the words cancer-free is the ultimate relief. The grueling treatments are over. But for many patients, that relief is temporary. Months or years later, the disease returns, and it often comes back far more aggressively. Conventional treatments like chemotherapy and radiation are primarily bulk reduction tools. They are designed to attack rapidly dividing cells and shrink the visible masses that show up on a medical scan. But these therapies act like a lawnmower on weeds. The blade cuts away the surface, creating an illusion of success. Yet underground, a resilient cellular root survives. Because this root remains, the tumor grows back, but now with biological armor, highly resistant to previous drugs. To genuinely stop a tumor from returning, medical focus must shift beyond shrinking the visible bulk. The true challenge is identifying and destroying that hidden, stubborn root. In biology, this root is known as a cancer stem cell. These are a highly specialized subpopulation of cells responsible for initiating the tumor, driving its spread throughout the body, and surviving the harshest chemical assaults. Pharmaceutical companies spend billions developing synthetic compounds to hunt down these specific cells. Yet researchers have discovered a highly potent, naturally occurring molecule capable of dismantling them, sitting right in the produce aisle. The source is the 3-day-old broccoli sprout. At this exact stage of growth, the young plant acts as a sophisticated biological weapon, packed with a compound specifically evolved to target cancer's most resilient cells. The active agent locked inside these sprouts is called sulforaphane. It's an isothiocyanate, a sulfur-rich compound that forms when its precursor, glucoraphanin, breaks down. Over decades of institutional research, this molecule has emerged as a premier cancer-fighting agent. Eating a standard mature head of broccoli is certainly healthy. But a fully grown vegetable simply cannot deliver the therapeutic concentration of sulforaphane required to eradicate stem cell colonies. Look at this chart based on Johns Hopkins data. A mature broccoli head registers near the bottom, while the concentration inside a 3-day-old sprout shoots upward, containing 20 to 100 times the amount of these chemoprotective compounds. Accessing this payload requires a specific chemical reaction. The plant contains an enzyme called myrosinase, which triggers the conversion of the precursor into active sulforaphane. If you expose the sprouts to high heat through cooking, that delicate enzyme is destroyed, and the conversion never happens. To maintain this multiplier effect, the sprouts must be mechanically crushed, either chewed thoroughly or blended raw into a smoothie, allowing the enzyme to mix and activate the medicine. Once absorbed, sulforaphane moves systematically through the bloodstream. It identifies and physically latches onto specific molecular markers found on the heavily armored exterior of a cancer stem cell. This data visualization tracks the results from a landmark University of Michigan study on human breast cancer. After exposing the tissue to sulforaphane, the stem cell population plummets, suffering a massive 65 to 80% reduction. The compound achieves this through epigenetic modulation. It acts as a molecular hacker, slipping past the cell membrane to alter the genetic instructions written deep inside the cancer cell's DNA. It actively downregulates, or turns off, the specific genes that promote tumor growth, while simultaneously upregulating the body's natural tumor suppressor genes. On top of this, sulforaphane induces phase 2 detoxification enzymes. In one study using freeze-dried sprouts, this accelerated the elimination of environmental carcinogens, the fuel for new mutations, by 67%. Sulforaphane rewrites the malicious code keeping the tumor alive, forcing the stem cell to initiate its own demise. The specificity of these mechanisms has moved the study of sulforaphane from the realm of dietary observation into active clinical integration, where it is being trialed as a strategic adjunct to standard chemotherapy. Pharmaceutical developers are actively isolating these properties. Scientists at the University of Manchester have developed Krug SSX-01, a stabilized synthetic version of sulforaphane designed specifically to reverse and prevent resistance to hormone therapies in breast cancer patients. In laboratory models, sulforaphane works in profound synergy with heavy chemotherapeutics like docetaxel. While the chemo attacks the primary tumor mass, the sulforaphane simultaneously hunts down the surviving stem cells, preventing the formation of secondary tumors. This points toward a dual strike model for oncology. Deploy standard, targeted care to clear the bulk of the disease, and use sulforaphane to salt the earth and eradicate the roots. For individuals actively managing a cancer diagnosis, clinical literature often points to a target dosage of roughly 2.5 ounces, about half a cup, of raw broccoli sprouts per day. For those focused purely on prevention, consuming that same 2.5 ounces every third day provides enough of the compound to maintain high levels of genetic defense. But there is a biological limit to consider. As with any potent compound, the dose makes the poison. Eating massive quantities, more than 4 cups a day, can overwhelm the digestive system, leading to nausea and gastrointestinal toxicity. Even though they are inexpensive and easily grown in a jar on your kitchen counter, they demand the respect of a concentrated medicine. Incorporating them properly into a raw salad or smoothie ensures safe, steady absorption. In the complex, high-stakes battle against cancer's most resilient cells, we are finding solutions in unexpected places. A tiny seed, given 3 days to sprout, contains a sophisticated molecular payload capable of striking the disease right at its roots.